Hi guys. So today we're going to shift a little bit from absolute value and we're going to move over to quadratics. So to start, we're going to review a lot of things that you guys did in Algebra 1, and then we're going to look at some new things that relate to parabolas. So the first thing we're going to do is we're going to review the quadratic parent function. So the quadratic parent function is f of x equals x squared. So if I'm going to figure out what this graph looks like, if you don't remember, we'll plot some points. If I plug in 0 for x, 0 squared is 0. If I plug in 1, 1 squared is 1. 2 squared is 4, 3 squared is 9. If I plug in negative numbers squared will give me positive. Negative 2 squared would be 4, negative 3 squared would be 9. So I'm going to go ahead and plot these points on my graph so we can see the shape. I know 9 is going to go a little bit off of it. And there is my quadratic parent function in the shape of a parabola. So going over just some of these characteristics and features, these things are going to keep coming back up throughout the rest of the year. So do not forget them. They are going to continue to come back. Domain would be from negative infinity to infinity. Range, bottom to top, would be from 0 to infinity. The increasing intervals, left to right, as what's happening, we're looking for where our y's are getting bigger. So that would be this section of the graph right there. So we're going to list the x values where that's happening. So those are the x's from 0 to infinity. Decreasing, that would be this section of the graph. We're again going to list the x values, which would be from negative infinity to 0. Positive intervals, so where this graph is above the y-axis. So in this case, it's almost the entire graph because this area is positive and this area is positive. But there is one place that's not positive. That is the place where it actually equals 0. So this graph is positive until 0, and then it continues from 0 to infinity. This graph does not have any negative intervals. Axis of symmetry, this graph, the parent function is even. It has y-axis symmetry. But the actual axis of symmetry is just going to be basically x equals that vertex. So in this case, it's x equals 0. Extreme. All right, so this graph has an absolute minimum, and that's at the vertex, which in this case is 0, 0. But our vertex is always going to be our minimum or our maximum. All right, end behavior. So what we do two things. So as x approaches negative infinity, we look and see what y is doing. And then we do as x approaches positive infinity, we see what y is doing. So as x approaches negative infinity, those y's are increasing. And then as x approaches positive infinity, those y's are also getting bigger. So that's end behavior. All right, so what we're going to do now is we're just going to review our transformations. So we did this in class with Pear Deck just to double check to make sure we knew all of our transformations. So x minus 4, that would go to the right. That negative on the outside, that would be a reflection over the x-axis. Number multiplied out in front, it's larger than 1, is a vertical stretch. Minus 4 would be a shift down because it's away from the x outside the parentheses. Inside the parentheses, these are horizontal changes. So let me change the color here. That negatives would be over the y-axis. That 2 would be a horizontal compression. Then the plus 2 would be the shift up. Then on this last one, that 1/2, that would be your vertical compression. And then that plus 3 inside the parentheses, it's horizontal and it's opposite, so that is going to the left. So then we just revisited that chart that we've made a few times before now. So f of x minus h is a shift right. F of x plus h is a shift left. B is greater than or equal to, that should say 1. That's a typo on your notes. That is your vertical stretch. If it's in between 0 and 1, that's a vertical compression. And that would be a reflection over the y-axis. So what that looks like on a quadratic, okay, that would look like x minus h in the parentheses squared. So all of these horizontal changes are going to be inside the parentheses. And then same thing with our reflections and our compressions. So if you just see a number that's multiplied or you just see a negative and it's not in the parentheses and underneath the squared, it is not a horizontal change. It'll be a vertical change. All right, so our vertical changes, again, that shouldn't say absolute value. Plus k would be a shift up, minus k would be a shift down. Greater than 1 is a vertical stretch. In between 0 and 1 is a vertical compression. And then that negative out in front would be a reflection over the x-axis. So on the quadratic equation, it is outside of the parentheses and away from the x. So if it's not in the parentheses with it, it's going to be a vertical change. So whenever we write these, if we have multiple transformations, again, we do want to factor out that b value. If it's there, it just makes it a lot easier for us to see our vertex. But our vertex is hk, so the opposite sign of the x, and then whatever is being added, subtracted on the outside. The other way that you can get your vertex, you can get the x-coordinate of your vertex using negative b over 2a, which is something you probably did back in Algebra 1, and we'll use that when we're looking at equations that are in standard form. All right, so now we're going to go ahead and just do a couple examples and graph here. So on this first one, we're going to start with listing the transformations. All right, so this has a transformation of right 1, up 3. It's been reflected over the x-axis, and it has a vertical compression. The vertex here is hk, so it is positive 1, positive 3 for a vertex. So when I graph this, I'm going to go ahead and plot my vertex first. Axis of symmetry is always going to be x equals h for our vertical parabolas and our functions. So then we're going to go ahead and sketch our graph. So the way we look at our graph, let's think about what the parent function does. So normally from the vertex, we moved 1 to the right and 1 up. From the vertex, we moved 2 to the right and 4 up. 3 to the right, 9 up, and 4 to the right, 16 up. That's just how we changed from the vertex on the parent function, because 1 squared is 1, 2 squared is 4, 3 squared is 9, etc. Well, this time it's going to be different. Because we have this compression and this reflection, we can't go right 1 and up 1. First of all, because of this negative, it's going to open down. And then because it's compressed by 1/2, we're going to move by less amount. We're not going to move by as much. So what we'll do is we're going to take, because it's affecting the y's, it's affecting the verticals, we're going to take what we usually change on the y's and multiply it by that negative 1/2. So that means from my vertex, I would go right 1 and down 1/2. From the vertex, I would go right 2 and down 2. From the vertex, I would go right 3 and down 4.5. And then from the vertex, I would go right 4 and down 8. Then because there's an axis of symmetry, I'm going to do the same thing on the other side of my graph. And that is my parabola. So once we have it drawn, let's go ahead and fill in the rest of these characteristics. Domain is negative infinity to infinity. Range bottom to top, lowest y value to tallest y value. Increasing, so left to right when the y's are getting bigger is this section of the graph. So we would list those values as negative infinity until the x value of 1. Decreasing, that's from 1 to infinity. All right, so now let's look at our next one. Again, let's start with listing the transformations. This graph has a vertical stretch, and this graph has gone left 3. So the vertex, hk, so opposite sign, so negative 3, 0. So we'll plot that first. Axis of symmetry will be x equals negative 3. And let's see how this graph has changed from the parent function. So normally from the vertex, right 1, up 1, right 2, up 4, right 3, up 9. But the change here is that it's been stretched vertically. So instead of going right 1 and up 1, right 2, up 2. Right 2, up 8. Right 3, up 18, which is not going to fit on our graph, but it would give us some additional points if we needed it. So what I'm going to do is from the vertex, move right 1 and up 2. From the vertex, right 2 and up 8. And then I'm going to have those same points on the other side of the axis of symmetry. Domain, negative infinity to infinity. Range, bottom to top, with a bracket because it does touch that point. End behavior. So as x approaches negative infinity, we look and see what y does. Y approaches positive infinity. As x approaches positive infinity, we see what y does, and that is also going towards positive infinity. Positive and negative intervals. So positive intervals is almost the entire graph. It is not positive, though, at 0. Negative intervals, there are none in this case. All right, so now what we're going to do is we're going to switch gears a little bit, and we are going to, there's an extra practice question if you guys want to work this one out. Actually, let me go ahead and pause the video and try it. All right, so your vertex would be at 2, 6. It's been reflected. It's been stretched by 3. So from the vertex, I went right 1, down 3, right 2, and down 12. And that gave me those points. All right, so now what we're going to do is we're going to find the vertex on the axis of symmetry when it's in standard form. So if it's in standard form, this should be y equals. So if it's in standard form, there's 2 things you can do. One option is completing the square. So if you remember that from Algebra 1 and you're comfortable with it, that is a good way to be able to solve this problem. If you're not comfortable with completing the square just because it's been a while, there's another method you could use to find the vertex. The x-coordinate is negative b over 2a. So remember, it's a, b, and c. So that means my b value, negative b, would be 2 over 2 times 1. So my x-coordinate of my vertex is 1. That means the axis of symmetry is x equals 1. Once I know the x-coordinate of the vertex, I plug it in, and then I can get the y-coordinate. So 1 squared minus 2 times 1 plus 3 is 2. So 1, 2 would be our vertex. All right, very similar on B. To get the x-coordinate, negative b over 2a, which is negative 1, which means the axis of symmetry is x equals negative 1. Then to get the y-coordinate, then that's negative 2 plus 4 plus 3, which is 5. So my vertex is negative 1, 5. So if it's in standard form and you don't want to use completing the square, that's another way that you can find the vertex and the axis of symmetry. If you wanted to graph this, you also could because you still know that a value. So this actually would still be reflected and have that stretch of 2.